Encapsulation. So encapsulation is the final pillar of object-oriented programming, and it really consists of a few things. Number one, we don't need to know the internals, or at least people that use our components, including ourselves, we don't need to know the internals of how these things work. We just simply need to know how to use them. And a car is another good analogy here because we don't need to know how a car operates internally in order to use a car. We just simply need to know how to use the interface and how to drive a car. All right, so we don't need to know how the engine works or anything else internally for that matter. We're just operators. And that's really what encapsulation is all about, is only exposing what we need to expose so people can use, including ourselves, can use our object without having to know the internal details. So I'm going to show you how you can create that black box effect here with our code modules and how we can actually create a code module. And we'll also take a look at code visibility and how we can control access to what can see and what can use our code. All right, so let's jump into the outline. We'll start with an introduction to encapsulation. Just want to go over some more about what encapsulation is and how we can really use it to make our code even more generic and more accessible. And then we'll look here at working with encapsulation. And here we're just going to just show you access modifiers, get you familiar with public, private. We'll take a look at protected internal, all of the different ways that you can control access and visibility from your code. And then we'll take a look at interfaces and how you can implement interfaces to do things like maintain backwards compatibility and to maintain our signatures and the structure of our code. And I'll really just get you familiar with what's the difference between an interface and an abstract class. I remember when I was learning this stuff, this was probably one of the worst things to learn. And I don't want to say, it's not a bad thing to learn. These are, once you get familiar with this stuff and how it works, really cool stuff and really powerful how you can design your applications. But it can be a little difficult to get the hang of right off the bat. So don't worry, you'll definitely pick it up with time, and I'll try to make it easy. I've got some good analogies and a really good demo here that should give you a good example of why and how we can use interfaces and what the difference is between an interface and an abstract class. Alright, so let's get to it here and start with an introduction to encapsulation. And again, there's a couple of different flavors of encapsulation. It's kind of another one of those umbrella terms that can mean some different things depending on the context. And the first thing you want to talk about here is just encapsulation when it comes to code visibility. And we control that through what are called access modifiers. And you see me use these up to this point. We've used things like public, private. These are the two big ones we've been using so far. And these can be tagged on classes, they can be tagged on methods, on properties, on events, so on and so forth. And all public means is that all code has access to it. So if you declare a public method, you'll be able to access that method from outside of the class or when you're using the class. If you declare a method as private, then when you create a variable based on a class to turn it into an object and you do, variable dot, you wouldn't see that method because it's private to the class, and only code within that class will be able to access it. And there are a few we haven't used yet. One of them is protected. And what protected means is if we were to create a method inside of our employee class here that was protected, only anything underneath employee would be able to utilize it or see that method and use it. So pretty much it boils down to derived classes. Derived classes, anything that's derived from a class can see a protected method. And finally here we have internal. And what internal means is anything within an assembly. What's an assembly? Well, an assembly is going to be your output. For instance, if we create a Windows Forms application project and we compile it, that's going to turn into an exe. That exe is considered to be an assembly. So anything within this, and you know what? This is the default. This is the default here. If you don't declare anything on it, everything that we've been using so far has been internal. We haven't had to explicitly define public or private or protected because we've always been working with one project. So everything's been internal at this point. And you're going to see, I'm going to show you how to break all the code, all of our classes out in this nugget here into its own assembly, a DLL file. So we have these things called class libraries, which are, just think of them as code modules because they don't contain any interface or anything like that. They're just modules of code. Well, we're going to create a class library, and that's going to be its own assembly. And the result from class libraries are DLL files, .dll. They're dynamic link libraries. So that's where internal comes from. And there's also one more in here. It's a combination of these two called protected internal. And that just means within the same assembly and only derived classes within the assembly. And this is where we can really start to create the black box effect using these. For instance, let's say that in our employee class, we'll go on this side here, say we had a method called do work. What a great method, do work, my favorite method of all time. And within do work here, let's say this is really our kind of our controller method. And what I mean by controller method is, let's say we have a bunch of other work in here. Let's say we have a method called work hard, and then we've got a method called work smart, and then we've got a method called lazy. Something like that. We've got all these methods down here. And this is our controller method because maybe depending on some properties that were set in our class, we're going to call one of these methods when somebody calls do work, because we want it to do something different depending on the state of our class. So maybe we'll work harder if a property is set, or maybe we'll work smarter, or maybe we'll be lazy, or maybe we'll do a combination of these. That's why we have a do work class, to figure all that out. So that's why it's a controller class, because it's going to figure out based on the state of the class which one of these or which combination of these to call. Well, rather than expose all of these as public, we wouldn't want to do that. We would really, not only confuse the people using this, but we want to create the black box effect, because they can set properties to change the state of the employee and then just call the do work function. So we would tag these three as private. This one is public, so they'll only have to work with this. They won't have to know the internal details of how this is going to happen. They just simply need to know how to set a few properties and then call the do work function. Just like in a car, you don't need to know when you turn your radio on how to turn it on. You just know that you push the on button and it turns on. You don't have to know, how the engine starts. You just have to put the key in and turn it to start it up. So that's kind of the basis of encapsulation there, and creating the black box effect. And another really, really big thing when it comes to this encapsulation stuff is, remember I mentioned in a previous nugget, signatures are important? Well, signatures are super important, because when it comes time to do updates and maybe release a new version, as long as your signatures stay the same, you won't have to recompile and redeploy anything that's connected to this class or to our component, because we're going to create this DLL file, right? And we may have lots of interfaces, lots of different products that all use our DLL file. Well, if we change the signature of do work and maybe add a parameter, we would have to recompile all the front ends to all the products to anything that ever uses this and redeploy it. Where if we just change the code in our methods down here, our private methods, we didn't change the signature, we didn't change anything in do work, and we could even change code in do work, just as long as we didn't change the signature. We could change these things, recompile, and just overwrite our DLL. We wouldn't have to do anything as far as reconnecting our front ends or any applications that uses our class libraries to this. That's a huge thing, and that's why signatures are super important. And that's kind of programming in the .NET's black box within itself, because it only cares about the signature, the structure, the name, followed by the parameter set, followed by the return type. It doesn't care about the implementation. It doesn't care about the code that actually does the work. All right, so that's kind of the reason, purpose, and why behind access modifiers. And that actually plays into interfaces as well, because interfaces are a way that we can not only group functionality, we can make really generic stuff using interfaces, and we can maintain backwards compatibility using interfaces. So with interfaces, I've seen people struggle with them over the years, and it is one of the more difficult object-oriented concepts, but with a couple of real-world analogies here and a good example on paper both, and then in C#, I think we can get the hang of it pretty easily. So, and the first question people usually ask is, why would I use an interface over an abstract class? Because they are very similar. And in fact, abstract classes, you cannot create an instance of, just like an interface, you cannot create an instance of an interface. But the difference is, abstract classes can contain implementation code. They can contain code within your methods to do something. And then we access that through our derived classes. Interfaces are different. Interfaces cannot contain any code in them, implementation code, right? Code that actually does stuff. Interfaces, you're going to hear this a lot. If you do any research on interfaces or reading on it, you're going to read that interfaces are simply contracts. Contracts that define signatures. They just simply define the method, the return types, and then the parameter sets. That's it. And everything in an interface has to be public. No private anything. They're all public. And the only thing you can have in interfaces are properties, methods, events, and delegates. So that's a contract. And we're not talking about contracts that people sign. We're talking about standards, contracts that we agree upon when using. And to give you another good example, a real world example here, think of a car again, and no matter what kind of car you get into, they're all going to work the same. So they're standardized. You're going to jump into a car and you're going to know that the right hand pedal is your gas pedal and that's how you drive. The left hand one is your brake and that's how you stop. Think if somebody came out with a car and reversed those. yeah, that'd go over well, right? Nobody would buy that car, and if they did, they'd be out of their minds. So uh, that's just a kind of an industry standard way of doing it, and that's a contract. That's a general interface. Same with the telephone. Look at the telephone. If someone came out with a phone that you know list and changed how numbers are ordered and maybe put the 9 where the 1 is and the 0 where the 9 is and offset everything, no one would want to use that phone because they're not used to it. It's not a publicly accepted contract. And so that's really what interfaces are about at that level. Let me give you some examples of how we could use an interface. The best way to think of when you would use an interface over an abstract class is think of an is-a relationship versus a can-do relationship. An is-a relationship we would use, that's perfect for a class like this. Employee is a person, character is a person, all these, developer is an employee. So classes are is-as. Interfaces are good for can-dos. And to give you an example here, remember we had a talk class? Or excuse me, a talk method inside of our class here, our employee class. Actually, we put it inside of our person class, and then we made that a virtual class, a virtual method that everything could override and supply their own implementation. Rather than put this inside of our talk method inside of our person class, we should turn that into an interface, and we should name that interface I speak. I speak would have one definition in here for the method talk. So what that'll allow us to do then is in our person abstract class, we could implement this interface. And if you ever see diagrams, you'll see it looks like a little lollipop. That means this class implements the I speak interface. And so what will that do for us? Well, nothing right off the bat other than now we're working based on an interface. But let's say that down the road in another product we wanted to create maybe an animal class, right? And our animal class would be an abstract class. And maybe under here we'd have some concrete classes derived from animal, one called cat, one called dog. So what we could do then is our animal class could also implement I speak. Right? So now, no matter if we're working with a person or an animal, even in the same product, we could create and call the talk method off a cat or off an employee through the interface. And that's another form of the whole black box and encapsulation and a lot of really powerful stuff that you can do using this technique. And if it still doesn't make sense, it will when we get into a demo, because we're going to do this. We're going to create an animal-based class, and then I'll show you how we can, through the interface, generically call the talk method, and .NET will be smart enough to call talk depending on, it'll know which one it is, a person or an animal. So we're just really making this even more generic. And interfaces are really, from a simple point of view, a way to group like methods. So maybe we could have other things inside of talk here, whatever else we have speak. So maybe we could have an accent property, a language property, things like that. And we could group all of this behavioral functionality here inside of our I speak interface and then implement it, not just in person or animal, but anything that has the capability to speak. And not only will that allow us to generically work with this stuff, but we can then query. Let's say that we have, maybe we're creating a video game. Video games are perfect examples of all this stuff because, they're pretty complex. They're some of the most complex applications out there, if you think about it. But think of a game that would contain people, animals, and anything else. What I could do underneath the hood is if I needed to find out all the objects in my game that spoke, maybe I needed to do something with them, like mute them or do something like that, I could query for the interface. I could say, give me all the objects that support the I speak interface, and then I could get them all, and I could do something against them all. So that's another really powerful way to use an interface, is now you can query all of your objects to find out which support what interfaces. On top of that, it gives us a great way to maintain backwards compatibility. Because let's say we've got applications out there that all use our talk method through our interface. great, they can continue doing so, but let's say we needed to add some extra functionality. Maybe we had a talk method that we wanted to take a parameter on, right? Whatever the parameter is. Well, what we could do is we could add to our interface this new method that accepts a parameter, and then any new applications can use the new talk method. And so when it comes time to deploy it, we're not going to break existing applications, because if we were to change our original talk method at a parameter, guess what? If we were to deploy our DLL that contained all this code, we would break any existing applications. Where if we add a method with talk with a parameter in it, then all the new ones would use this one, all the old ones would still use the old version of talk, and it's a great way to maintain backwards compatibility. And this is how we did it back in the old days in Visual Studio and Visual Basic 6, and before C# came out and before object-oriented programming came out. The only way to support this kind of stuff was through interfaces. So there's kind of a crash course on encapsulation and how we can work with interfaces. Let's jump into the code and see how we can do this. And we're going to do exactly this here. When we get into interfaces, we'll make an I-Speak interface, and we'll create some animal-based classes, and I'll just show you generally how we can work with this stuff. But first, let's talk about encapsulation and how to work with access modifiers. So I'm going to minimize whiteboard, head over to Nugget Lab, and let's head down to the Start button in Nugget Lab here. Open up Visual C# 2010 Express. Got a solution, 09 encapsulation. And again, we're exactly where we were, if you're following these sequentially here, in our previous Nugget when we looked at polymorphism. I haven't changed a thing, so everything is the exact same with some name changes is about it. And the first thing I want to do is show you how we can take our classes, break them out into their own assembly. Alright, so let's do this. Let's right click on the solution, choose Add, New Project. We're going to add a class library. And let's just call this class library here Encapsulation Library, just to keep with our naming conventions here. And then in here, I'm just going to delete our class 1 out of here. There we go. And I'm going to take our classes in here, and I'm just going to drag them up into this library. Alright, and I'm going to delete them out of our WinForm project. And now, from here, what we need to do is from our WinForm project, if we want to use all of our classes up here in our library, we're going to have to set a reference to it. So if we right-click on our project and choose Add Reference, you can see it's going to default to the Project tab. We can add a reference to our encapsulation library class. And just to show you, I'm going to click on .NET tab. Look at all the libraries here that are built into this specific box here, Windows 7. Look them all. So there's a ton of things we can do. If we wanted to, for instance, work with things like, let's scroll down here and see what we got. Speech. Here you go. If you wanted to incorporate speech functionality in your applications, you could set a reference to this code library, create objects out of them, and start working with them. And again, this is that black box effect. You don't need to know how to write all that and make your own speech code. You can just simply tap into this code library and examine the objects within it, or the classes within it, create objects from them, and just start messing around with it. So these are all code libraries. And that's exactly what we're doing here, is we're making our own code library and putting our classes inside of it. So that's all these are, just code libraries that contain classes. And that's that whole black box effect too, because we don't need to know how they work. We can just tap into them and use the code that's built into them here. And you can also browse here. You know, if you've got anything that wasn't listed in there, you could browse to one. If you downloaded one from somewhere that you wanted to use some code, you could just browse right to it. But since it's contained inside of our specific solution here, we've got our list of projects. We're just going to hit OK. And inside of your references, here it is. Now we should start being able to use all of the code that we've built in the previous object-oriented nuggets here by just using our library directly. And now we should, theoretically, be able to build this. If I right-click and choose Build, which is the same thing as do and run, we're going to get some errors here. And the errors that we get are, just bring this up a little bit so we can see it. There we go. Inaccessible due to its protection level. Yeah, you know what that is. That's because, as I mentioned, everything defaults to internal. So if we look at, say, our employee class, it's just class employee. So this defaults to internal, and guess what? That means anything within this assembly. Remember, this is an assembly here. It's a DLL file. It's its own assembly. Same with this. It's an assembly. And since we took it out of here, our WinForm project has no idea where character is. So you know what we need to do is we need to go into employee and make this public. All right, we need to do the same thing here with our character class. Let's make it public. Let's do the same thing with our, well, we did make this our person class public. There we go. And then our salesperson class, we also need to do public. So now, let's try it again. Let's rebuild. What do we get? Hey, look at that. Rebuild all succeeded. Now we should be able to work with this just like we were in the past. Everything should work the exact same here. I can talk. I'm an employee. John Doe can talk. He's a salesperson. So on and so forth. So the only difference is now we've broken it out of the project, put it into its own library, and then we changed its access modifier to public, so everything outside of this assembly can work with it. So the rest is pretty straightforward when it comes to using access modifiers. In fact, if we head over to our person class, we already did this. We already have the black box encapsulation effect going on here with is sleeping here. Remember, our is sleeping is a property that we expose through a private variable. So this variable is only accessible to our person class, and then we expose it through a property. Again, this was the only way to really do things prior to .NET 4 and automatic properties, which was technically prior to .NET 3.5. All right, let's move on to interfaces here. And what I'm going to do is I'm just going to copy this namespace because we're going to create a bunch of new classes inside of here. We want them to default to this namespace. So this is how you can do this. You go to right-click on your project, hit Properties up, go to your default namespace, and we're just going to change it to that. Now when we create new classes or interfaces, it'll have the namespace by default. And the other thing I'm going to do is I just want to group things in here a little better. So I'm going to right-click on the project, add a folder, and let's just call this our person classes. We'll drag all these into our person classes folder, and let's create another folder here. We're going to call this animal classes, like so. So we're ready to go here. We've got everything set up. Let's add an interface into here. I'm going to right-click on our library, on our project here, choose Add, New Item, and we're going to add an interface. And let's just name this interface I Speaks. And this is kind of the naming convention. Anytime you see an interface out there, it's going to be tagged with an I. That's how you'll know it's an interface. All right, let's hit Add. And now we've got our I Speaks interface down here. If we open it up, which it was by default, you can see interface I Speaks. And then we're going to make this public so we can access this interface when we need to down here in our WinForm application. And all we need to do is just define the structure. So we just want a talk method. Let's just do this. Public and a string here because we're going to return a string value. Talk. That's it. That's how you define an interface. And in fact, it may not even like public. If I rebuild this, yeah, see this? It's not valid. Why? Because everything's public by default. We don't have to. You don't define access modifiers inside of your interfaces because everything is public. All right. There's no private. There's no anything but public. So if you define any properties, you just define them with their data types. Define any methods here. It's either going to be void or the data type, and then same with events and delegates. And again, that's because it's just a contract. All right. So now we need to implement our interface. And how do we do that? Well, let's go into our person class, and we're going to do this in our base class. That way we don't have to do this in every one of our drive classes because it makes sense. Everything underneath the person is going to be able to speak, or you call the talk method. So therefore, all we do is this. It's just like using a base class, where if you're already deriving from a class and you want to implement it, just to show you here, if we go to our employee class, we're already going from person. We'll put a comma, and then we can do an I Speaks. All right, and you can implement multiple interfaces, as many as you like here. You can see if just type in an I, you'll get them all. All right, so, and there's a ton of them in here. So that's how you can do a base class, or derive from a class and use an interface. In our example, our person class isn't derived from anything because it's kind of our abstract top of the hierarchy base class, so we can just use a colon followed by I Speaks. And now the other thing with interfaces is if you implement an interface, you have to provide code for everything in that interface. All right? Because if you don't, you're going to get errors. In fact, if we go down here, we don't have to change anything because we already do. But let's just say we turn this to talks. And I'm going to rebuild our library here. See that? Person does not implement interface member talk. And it yells at us. It doesn't like it. So what we need to do is change this back to talk. And now let's rebuild it. And see that? We're good to go now. So we didn't even have to change anything here because we already implemented talk. It's just that we moved it to a contract, to our interface, and then implement it. But since we already had the code in here for talk, we didn't have to do anything. In fact, we don't have to do anything because this is virtual to any of our classes. So we're just speaking through the contract now. All right, let's take this a step further and get some animals in here. So I'm going to right-click on our animal classes and choose Add Class. And here, let's add an animal base class that we're going to work with. And we'll just leave the namespace here. You can see it depends on the folder name since we've got a folder. That's fine, we'll leave that. And let's just make this a public abstract class animal. And since this is our abstract class and all animals have the ability to speak here, we're going to implement iSpeaks. And what other things are we going to have in here? How about we track a name for the animal. So public string name is going to be a get and a set here. And then we just want to utilize our talk method here. And in fact, if you right click on your interface, you can choose implement interface here. Look at that, it writes the code for us. Only we're going to make this abstract because again, it's an abstract class. Calling animal by itself, we're not going to have the ability to talk. So let's just do a public abstract string. All right, and then we'll force the other animal classes that make this our base class write the actual implementation for talk. So let's do that. Let's right click on animals, add another class here. Let's add a dog in here. Here we go. And for dog, if we just, we're going to obviously here, this is going to have to derive from animal, right? There we go. And we'll right click on animal, implement the abstract class. Here's our talk method. Let's just return roof. Not sure how to spell roof, but that looks good. And the other thing we want to do here is let's just override the toString method. And let's return dog, because we're going to use this in the interface, so we want it to be able to see that. All right, let's add one more in here. Add class. Let's add a cat. And let's just do the same thing here. So you are going to derive from animal. We're going to implement your abstract class here, and we're just going to return meow. Something like that. And then we'll just do the same thing here with our overrides on the toString. There we go. And this is going to return cat. So the main thing to take away from that is we've got an iSpeaks interface with our talk signature, right? And then we've got our person base class here that contains the actual reference to our interface, and then we just kind of expose it. In this case, in our person class, we expose it virtually, so we can throw some code inside of here, and then give our derived classes the ability to override it. And our animal class just simply abstracts it and forces our cat and our dog to override it with their specific implementation. So we're seeing it all here. Everything you can possibly do with object-oriented programming, I think we've accomplished in our demos. Let's take a look at how we would utilize this stuff in the interface. And this is where you're really going to see the power of this stuff come into play. So let's head down into our encapsulation form. And I'm just going to work some magic here to make this a little bit different so we can add some support for animals in here. All right, so I'll be right back in 1 second. And voila! Told you I would only be a second. So here we are. I added a list view down here called animal LV animals, list view for animals, with an animal name and an animal type. All right, and then I went into the back end here and just put some code in here, so you don't have to watch me write it all. But because we put this in an animal classes segment here, I had to put in using statements so we can import those, so we could work with our animal, cat, and dog classes inside of our code here. Otherwise, we would have just had to reference it by saying animal classes dot animal. All right, so I did that for a shortcut. And then we have an animal. We reference our abstract class here, and we have a reference to a current animal. So it works the same way it's been working with our people. We're going to store whatever animal is currently selected inside of our animal variable up here. And the only other thing we need to do here, I need to call load animals here, because just like load people, I made a load animals method. If we scroll to the bottom down here, here it is, load animals. So we've got Sparkles the cat and Sparky the dog. All right, made a couple of variables here, and then we call load animal list view, where we pass in the name of the animal, and it's going to load it to the list view appropriately here using the name, and also calling the .toString. That's why we overrode the .toString there, so it would go in there. And then we just store the animal inside of the tag property. so that way it'll get referenced properly. So everything works the same as our people did. And the only thing I didn't write the code for was how to work with our interface, because we're going to do that. Otherwise, everything else is the same. I added this LV animal selected index changed here. That way, when they click on an animal, we store the animal that's in the tag into the current animal variable that we made above. So the only thing we need to do is change our talk method right here. And by the way, before we do that, one thing I also had to do that we didn't do is I forgot to put a public before our cat class. and that caused problems because when I went to build this, I got those silly encapsulation errors or access modifier errors that it couldn't find cat because its protection level wasn't set right. So be sure you do this kind of stuff. Make sure it's public, explicitly define it. That way you won't have those surprises when you try to build your application. You get a bunch of errors that pop up. So cat and dog I made public. That way we could access it over here in our front-end application, our exe project. And now let's write some code. So here's the power of interfaces and how they work. What we're going to do, let's just get some white space here to work with. We're going to create an iSpeaks variable. And we're going to call this variable talker. Oop, not tailker, talker. Here we go. And now what we're going to do with this talker is we're going to put into it, depending on what's currently selected, we're going to put into it either an animal or a person. So it doesn't matter how we call it, we're going to call it. So because they both support this interface. So we can call talk from a person or an animal generically, and you're going to see this is kind of neat how this works. So the only thing we really need to figure out is which one has the focus. Because if they selected a person and then they hit the talk button, this list view is going to have the focus. If they select an animal and hit the talk button, animal is going to have the focus. So that's easy enough to figure out. Let's just do an if. We'll do this based on the people here. People.focused equals true. And you don't even need to do the equals true. That's just the default. So you can just do this. And that just means, if this returns true, then the if is good to go. Then we're going to set talker equal to the current person. Else, we're going to set talker equal to the current animal. And now, instead of calling current person.talk, we can call talk through the interface. Pretty cool, right? It's neat that we can create a variable of the interface type and then set whatever we want to, whatever supports iSpeaks, we can set it equal to that, and then call the methods through the interface. And that's the real power there on how we can use interfaces and call methods through them. So let's test this out. Let's hit run. And here's Sparkles the cat. Meow. Here's Sparky the dog. Ruff ruff. And then here's myself, hello, as an employee. And same with John Doe there. So see that? We're calling these methods through the interface. And that's the true power behind interfaces. So I hope that makes sense. I remember learning this stuff. It was not, definitely not the easiest thing to learn when it comes to interfaces and object-oriented programming. Probably some of the most difficult stuff to master, actually, in all of programming. But once you have it down, there's nothing you can't learn as far as programming goes, because really this is some of the most difficult stuff. But seeing it in action here, it kind of makes sense, right? Because now you can see how you can create these generic interfaces, use the interfaces to call the methods, and really truly start to create some generic and powerful code. Now the last thing I want to show you real quick is just the output from this. What the final version of our assembly looks like. If we right click on our library and hit build or rebuild, doesn't matter which one, and hit F4 here, I'm just going to go into our project folder by copying this. Let's go to start, type it in here, and we go into our bin directory. That's where everything goes when you build it. Debug is the current environment we're pointed at here. There it is, encapsulation-library.dll. So this is where all of our classes are contained, and if we wanted to reference this from any other projects that we're working on, we just set a reference to it, and boom, we can start working with these classes. And just to show you here, if we go back a few levels, here's our win form, here's our bin, debug, there is our exe. Actually, we got to build our exe. Let's do this. Right click, build. Now if we head over to here, we should, somewhere in here, get a encapsulation.exe. Here it is. It's in the release here. We've got that set up as a release. So there's our exe. Here's our DLL. It pulls it in and copies it locally so it has it and it references it. So our exe, if we were to double click on this, check it out. So now we're running live on the desktop, and it's utilizing the code libraries here inside of our library. Alright, so in this CBT Nugget, we took a look at encapsulation. We started off with just the basics, what encapsulation is. We saw encapsulation in a couple of different lights here. One was through code visibility and access modifiers. We looked at public, private, protected, internal, and protected internal. Just briefly talked about those. And we took a big look here at interfaces and talked about how we can use interfaces not only for generic kind of programming, but also to support backwards compatibility. And then we jumped into a big demo here, got you familiar with how to create your own class library and take your classes and put them into a class library so you could create your own assembly here. That being a class library assembly is a DLL file. And then we took a look at how to implement interfaces and saw you how you could create an interface, use it in a generic manner to call methods on it depending on the type of the object. I hope this has been informative for you, and I thank you for viewing.